log base 2 of x squared plus 5x plus 10 equals 4. All right, so I've got my variable stuck inside of a log, so I'm going to go ahead and exponentiate with a base 2 to get rid of that. If you're comfortable, you don't have to show me this step, but make sure you're really clear on what exactly is happening here, or you're going to get in trouble. So we push the log base 2 up into the exponent, and we push the 4 up into the exponent. This is a spot to really watch out. People will flip-flop, and they'll do 4 squared instead of 2 to the 4th, which interestingly here wouldn't get you in trouble, but generally it would get you in trouble if you flip-flop those. Okay, so 2 and log base 2 are inverse operations, 2 to a power and log base 2. So we're just going to be left with the x squared plus 5x plus 10, and then 2 to the 4th is 16. This turned my log equation into a quadratic equation, so let's go ahead and subtract the 16. And that looks factorable. I think I can go x plus 6, x minus 1, which means x could be negative 6 or x could be 1. We have our non-optional check here. This is a log equation. Okay, so if we check the negative 6, we get 36 minus 30, which is 6, plus 10, which is 16. So log base 2 of 16 equals 4. Okay, so it's definitely not extraneous. I'm not getting any domain problems on my log. And even more than that, I can say that it definitely looks right. 2 to the 4th is 16, so that's a good sign. If I check the x equals 1, I get the log base 2 of 1 plus 5, 6 plus 10, same thing, which means once again, not only is it not extraneous, I don't have any domain problems here, it's also a completely true statement, so I'll get to keep both answers here. Okay, 2 more to go. This one is exponential. I would like to get the variable out of the exponent. Because this is an exponential with a base 10, I'm going to use a common log. Once again, you could actually use any log you want and it will work, but it will be a little bit less messy if you choose a log that cancels out part of this. In particular, I really like canceling out the 10. You could choose a log base 24 though, and then this would work out really nicely. Okay, so if I take the log of 10 to the x squared minus 1, I get x squared minus 1 equals log of 24. And this looks sort of terrible, but remember, we're solving for x. So in this case, I only have one x on one side of the equation. I can just reverse order of operations to solve for it. You also have the possibility of using a quadratic formula on this. You could set it equal to 0. If you're going to do that, I would just point out that you need to realize that your a is 1, your b is 0 because there is no x, your c would be negative 1 minus log of 24. That whole thing is your c. So feel free to check that out if you're interested. You should get the same answer. What I'm going to do is add the 1. Be really clear here that you cannot add it to the 24. The 24 is stuck inside of the log, so you'd have to take the log before you can add. And then we can square root both sides. Don't forget your plus or minus. And there are 2 possible answers. I don't have to worry about extraneous solutions here. I didn't start with any possible domain problems. This is exponential, so that's not going to happen. If you want to step through, square this, square will get rid of the plus or minus for you. You'll get the log of 24 plus 1 minus 1. The 1s will drop away, then the 10 to the log of 24 will give you 24. So it does check out, but you do not have to check that one for extraneous solutions.